Welcome everyone. Today we're diving into a critical topic for building scalable, cost-efficient systems: intelligent log batching. In the world of high-traffic applications, every network call carries a hidden cost, and understanding how to minimize this is key to performance and infrastructure savings. By the end of this lesson, you'll gain practical insights and be equipped to implement these strategies in your own projects. Specifically, you will be able to, first, understand why network overhead is a critical bottleneck in modern systems. Second, you'll learn to implement core batching patterns like dual trigger and bounded queues, which are fundamental to efficient data handling. Third, we'll cover how to design your systems for graceful degradation and ensure data durability even when facing high loads or unexpected failures. And finally, you'll understand how to optimize batch payloads for maximum efficiency and apply these real-world strategies used by leading tech companies. Let's get started. Let's first understand the core problem. The network is your bottleneck. Every single log transmission, no matter how small, incurs significant overhead. Think about it. TCP handshakes, TLS negotiations, HTTP headers, and even kernel context switches. At scale, this overhead isn't just a minor cost, it dominates your infrastructure expenses. Imagine Netflix processing over 500 billion events daily. Sending each individually would be astronomically expensive and inefficient. This is where batching comes in. We accumulate data points and wait for a trigger before transmitting in bulk. The fundamental challenge is balancing latency and throughput. Production systems solve this with dual trigger batching, flushing when either a batch size or a time interval is reached, whichever comes first. For example, sending 1,000 logs or waiting 5 seconds. This ensures you get high throughput during peak traffic and bounded latency during quieter periods. Another critical pattern is using bounded queues. Without them, an overwhelmed producer can lead to unbounded memory growth, eventually causing your system to crash due to out-of-memory errors. Bounded queues apply back pressure, preventing this memory leak by either blocking new logs or dropping them when full, depending on your strategy. While batching boosts efficiency, it also introduces complexities around resiliency and data durability. What happens when your system is under extreme load? You need a strategy for graceful degradation. This means deciding what to prioritize, maintaining low latency by dropping some data, or ensuring durability by accepting higher latency.